So today we're going to be talking about graphing linear and absolute value inequalities. And so up there on the board, we are defining what a linear inequality is. And a linear inequality looks like a linear equation, but it has an inequality sign instead of an equal to sign. Okay, and notice this is an example of a linear inequality. And the thing with an inequality is that you don't just have a line as your answer. You actually have a shaded portion. And what that means is that any point in this shaded region will fulfill this inequality and make it true. So we're going to go ahead and look at how you can graph these from hand, or by hand. So if you have your goal sheet handy, okay, what form is this equation in? What form is that equation in? Standard form, right? And in order for us to graph this line, we need to know the slope and the y-intercept. So there are two ways to do this. One, I could put this into slope-intercept form and solve it, which some of you might like to do. Or I can use the far right column of that chart I gave you. And it says that the characteristics of an equation in standard form are, the slope is negative a over b. If you remember, this is 1x. And so here's my a, here's my b, and here's my c. So I can automatically know that my slope is negative a over b. So in this problem, negative a would be what? Negative 1 over 2. So my slope is negative 1/2. And like I said, if you get this, great, it can save you some time. If you don't, put it into slope-intercept form and solve it. Okay, my y-intercept is c over b. Well, what is c in this problem? 4. What is b? 2. So what's 4 over 2? 2. So that's my y-intercept. So how I graph this is I'm going to put a dot at 2. A slope of negative 1/2 means you do what? I go down 1 from this point and over 2. I go down 1 and over 2. Now the question is, do I use a dashed line or a solid line? In this problem, you will use a dashed line. The reason why is there is no equal to sign underneath this inequality. If it would have been this way, you would have used a solid line. So let's go ahead and draw a line through that. Okay, and it is a dashed line. There we go. So now the question is, we need to figure out what direction do I shade? Do I shade above the line or below the line? So the easiest way to do that is to pick a point. So I'm going to pick a point that's above the line or below the line. I'm going to actually pick the point 0, 0. So I'm going to plug in 0 for x and 0 for y into the original equation. So I'm plugging 0 here and 0 here. So basically, when I do that in standard form, the left side of the equation becomes 0. So if I look at this, is 0, what's that symbol mean? Greater than 4. Is that true?
No.
So I am not going to shade on the side with 0, 0. I'm going to shade on the other side. And that is going to be your answer.
Do we have to legit shade it?
Shade it, yes. Yep. All right, so we're going to look at another one, and then we're going to use GeoGebra to finish the last two that are absolute value inequalities. Okay, so let's go ahead and look at this one. 2x plus 1/2 y are as less than or equal to 2. So let's find the slope. Let's use our nifty little way. What is a in this problem? 2. What is b? 1/2. What is c? 2. So to find the slope, it's negative a, so negative 2 divided by b, which is 1/2. What is negative 2 divided by 1/2? Negative 4. Good, so that's my slope. What's the y-intercept? It's going to be in this problem 2 over what? 1/2 again. So what's the y-intercept? 4. So I'm going to start by putting a dot there at 4. What does the slope of negative 4 mean? Down 4 over 1. Down 4 over 1. What type of line am I going to use here, folks? A solid line. The reason why I'm using solid as opposed to dashed is because there is an equal to sign present there. There we go. Okay, so now I need to figure out what side of the line am I going to shade. So I'm going to pick a point. What point you want to use? 0, 0. That is on one side or the other. So I'm going to plug in 0 and 0. So effectively, what's the left side of my equation now? So 0, and then I look at this. So basically, I'm just going to look at the inequality portion. Don't worry about looking at the equal to portion. So is 0, what's this symbol? Less than 2. So 0 less than 2?
Yeah.
Yeah, so what side am I going to shade? This side, yep. I'm going to shade the side with 0, 0.
You use 0, 0 every time.
Yep. Well, you can use 0, 0 every time unless 0, 0 is actually on the line. And then you need to pick another point. So, those are pretty easy. Okay, let's go ahead and look at this next equation. Now, this is the beauty of GeoGebra. Why it's so nice. This is what you need to go. Did you everybody get it started? You should notice it should be on the desktop because I have went ahead and put it pretty much on all the desktops. Okay, if not, somebody maybe in your table has it up.
Does it look like
Okay, when you get GeoGebra started, and maybe someone took it off, but on GeoGebra, what I want you to go ahead and do is instead of doing y equals, I need you to go ahead and type it in exactly as you see it up there in the blue. Okay. So y and then the greater than symbol and ABS x minus 4. Can I use that real quick to grab? That's what you're going to do.
Yeah, mine's zoomed in.
Okay. That's what you're going to get. Ooh, okay, just wait. Just wait. Okay. Oh, yours is different.
Mine always does.
I better go quick after a while.
Oh, okay, good. I was gonna say.
Are we supposed to come up with different answers?
No, you shouldn't.
Oh,
This is what you should end up with.
I
Okay.
didn't want to get.
So then now, what's going to happen is you're going to translate that to the graph. And if you notice, where's the tip of that V at? It was at -4. And so the graph actually looks something like this. And you can see where is it shaded in GeoGebra, the inside of the V or the outside? The inside. So this is all you're going to do. You're basically going to translate what you see. Now, things I'm looking for on this for correctness. I'm looking to see that you have the V at the correct point. Okay, that is one of the things I'm looking at. And I'm looking to see as if your line goes the correct directions.
Do you have to do certain colors on the x-axis too?
Actually, it goes up 1 and over 1 every time on this one. Okay, so that's what you need to make sure that you do. Okay? If you didn't catch that, there was questions about specific points here. You need to make sure that this one goes up 1 over 1 every time, and you can see that on your graph. Let's look at the next one. Y is greater than or equal to. Oops. Now, this is something you can do. Okay? You can try this one first of all. Did anybody try graphing it like this, putting a greater than and then an equal to sign? Somebody try that and see if it works.
Yeah.
Did it work?
Yeah.
Okay, good. That's how you're going to have to enter it in if it's got an equal to sign. So things we're looking for on this one, we're looking for the tip of the V.
No, it's fine. I forgot to start it before, so.
So where's the tip of the V on this one, guys?
Illegal argument.
-1 here or -1 here? Here?
X-axis.
Okay? Now this one isn't probably going to go up 1 over 1 every time, is it? Where does it intersect the y-axis at? 3. So see, this one's a narrow one. So this is the nice thing about absolute value. Since you see it's at 3 here, okay, real quick, since you see it's at 3 here, you know it's going to be at 3 over here because it's a V and it's symmetrical. Solid line or dashed?
Solid.
Solid, and which way are you shading? Inside. Okay.
When do you shade the outside?
When it's shaded on the graph. You basically just have to look and see what it is. Okay, any questions? All right, your assignment then, and you have the rest of the time to work, especially with the GeoGebra, you have 10 problems to do. Okay, you have 8 through 26, the evens. 18, 20, yeah, 10 problems, okay, and you need to go ahead and get those done for tomorrow.
Can you go back
Right.
to the